My name is Hailey Harman, and this video is about the explosive pentaterraerythritol tetranitrate, also known as PETN. PETN is a highly explosive organic compound composed of carbons, nitrogens, and oxygens. This explosive compound is formed by reacting pentaterraerythritol, C5H12O4, with nitric acid, HNO3. Now that you know what PETN is composed of, how does it form? The oxygen in pentaterraerythritol has a negative dipole due to its high electronegativity. This means that the electrons in the oxygen-hydrogen bond are going to be held predominantly with the oxygen, making the oxygen have a negative dipole and the hydrogen, being electron deficient, having a positive dipole. This also pulls the electrons away from the carbon that's connected to the oxygen. This makes the carbon have a slightly positive dipole as well. This reaction is not necessarily favorable since an OH would be the leaving group. This hydroxide group is not very stable once it breaks off from the rest of the molecule. The oxygen in the hydroxide group does not stabilize the negative charge that is obtained by taking the electrons from the bond very well. To make this reaction more favorable, we can protonate the OH group that is on pentaterraerythritol. It is important to point out that in nitric acid, the same electronegativity patterns are followed. The nitrogen is a lot less electronegative than the oxygen. This makes it so that the electrons in the bond between the nitrogen and the oxygen sit predominantly with the oxygen. This makes the oxygens have a slightly negative dipole and the nitrogen have a slightly positive. The same thing happens with the hydroxide group in nitric acid. The oxygen is a lot more electronegative than hydrogen. It's going to pull those electrons in the OH bond, making hydrogen very positive. The negative dipole from the hydroxide group in pentaterraerythritol is going to pull on that hydrogen. The bond between the oxygen and the hydrogen in nitric acid is going to be lengthened and weakened as the bond between the oxygen in pentaterraerythritol forms with the hydrogen in nitric acid. These processes happen simultaneously. As the bond between the oxygen and pentaterraerythritol is formed with the hydrogen in nitric acid, the bond between the oxygen and the hydrogen in nitric acid are being broken. This process now gives the hydroxide group in pentaterraerythritol an additional hydrogen. This is very unstable for oxygen since it does not like to hold that extra bond. One of the oxygens that has a negative formal charge in nitric acid is going to be attracted to the positive dipole carbon in pentaterraerythritol. This attraction is going to begin to form a bond just as it did in the protonation process. The oxygen is going to be very willing to leave the molecule since it will become more stable once it breaks its bond with the carbon. As this bond is being broken, the oxygen in nitric acid is attaching itself and forming a bond with the carbon in pentaterraerythritol. Once this process is finished, you are left with two compounds, pentaterraerythritol tetranitrate and water. The background of PETN is somewhat significant when talking about why it is important to us today. PETN was first manufactured in 1984 in Cologne, Germany. It went into full production in 1912 and was used by the German military in World War I. Still not seeing why this is important? Well, it's important because this explosive is still used today. It is not hard to find, and it's not that hard to make, which makes it very popular among terrorists. It cannot be detected by screening machines in airports, which makes it dangerous for us who fly on these planes, where this explosive can easily be concealed within someone's sock. Small amounts of this explosive have very large effects. And even though it was manufactured a long time ago, it's still just as dangerous as it was back then. This explosive was used in war. PETN is detonated with a shock wave or heat. The nitrogen groups in pentatererythritol tetranitrate are very unstable. The lack of stability arises from the amount of energy in the final product of pentatererythritol tetranitrate. When producing the product, the reaction undergoes an endothermic reaction, adding energy into the system. However, this makes it very unstable since the energy has nowhere to go. Once it is ignited, an exothermic reaction occurs to release all of the energy that is built up in the product, and an explosion occurs. Now that I've rehashed you on some of the background of PETN, here are some of the properties. PETN is insoluble in water. It has a boiling point of 180 degrees Celsius, and of course, it is highly explosive.